Hi, everybody. It's Professor Mitchell. Continuing with Chapter 3. In this video, we're looking at Section 2.3 on solving linear equations, which is really a continuation of the last section. And in this section, we will apply a general strategy for solving a linear equation, solve equations containing fractions, solve equations containing decimals, and finally, recognize identities and equations with no solution. And the student learning outcome for this section is to solve linear equations. Once again, I'm skipping the words that don't apply to this particular section. So what you're going to notice in this section is that the examples are a little fancier than they were in the last section. So I am going to share with you now a list of steps that will work with pretty much every linear equation. Step 1, multiply both sides by the LCD, least common denominator, to clear the equation of fractions if they occur. And I will show you an example of where we do that. And by the way, this step could also apply to clearing decimals. I'm going to show you an example with decimals where you can do something like this if you want to. I'll talk more about that when we get there. Step 2, we'll use the distributive property to remove parentheses if they occur. So look on both sides of the equation, see if there are any parentheses. And if there are, you should be able to get rid of them by using the distributive property. Step 3, simplify each side of the equation by combining like terms. In other words, look for like terms on the left side and look for like terms on the right side. Left side and right side separately. All right, in step 4, we will use the addition property of equality. We talked about that in the last section to get all variable terms on one side and all numbers on the other side. Step 5, we'll use the multiplication property of equality to get the variable alone. And then finally, it's always a good idea to check the solution by substituting it into the original equation. So I will continue my tradition of doing the check in maybe about every other example, just so the video is not super long. All right, so at this point, I'm just going to switch right over to the tablet because I've got 4 examples here. The directions for all 4 problems is solve the equation. So let's just go over to the tablet. No sense in showing them to you here and then showing them to you again in the other place. All right, first example, we have 5 minus 6 times 2 plus b equals b minus 14. So I'm going to talk you through the steps that we just talked about. Step 1 is to remove fractions if there are any fractions. In this case, there aren't. Step 2 is to use the distributive property to get rid of parentheses if there are any parentheses, and in this case there are. So let's distribute a -6 there, and that's going to give me 5 minus 12 minus 6b equals b minus 14. Okay, so we've gotten rid of all the parentheses. So now we move on to step 3, which is to simplify each side of the equation by combining like terms. There are no like terms on the right side of the equation. It's just b minus 14. But on the left side of the equation, we have 5 minus 12. So those are like terms. So I'm going to combine those. 5 minus 12 is -7. All right, we move on to step 4, which is to use the addition property of equality to get all variable terms on one side and all numbers on the other side. And typically, when you do this step, you have some choices. For example, I could choose to put the variable terms on the left side and put the numbers on the right side, or I could put the variables on the right side and put the numbers on the left side. It really doesn't matter. I find that sometimes students just get into the habit of always putting the variable on the left side, which is fine. All right, so let's do that first. If we're going to put the variable on the left side, that means we need to get rid of this b on the right-hand side. We do that by doing minus b on both sides. So now we have -7 minus 7b equals -14. Since I've put the variable terms on the left side, I need to now put the numbers on the right side. So I need to get rid of that -7, and I'm going to do that with a +7. And now I'm going to have -7b equals -7. All right, and now we're on to step 5. We're going to use the multiplication property of equality to get the variable by itself. The multiplication property of equality says that you can multiply or divide any number you want to on both sides except for 0. So I am going to divide both sides by -7, and that is specifically to get rid of this -7. It's just a coincidence that that's also a -7. All right, so it looks like the solution is b equals 1. Since this is the first example, I will do the check. So I take my original equation, and I want to know if it's true that 5 minus 6 times 2 plus, we'll leave that blank for a second, is equal to blank minus 14. Okay, is that true when we put a 1 in there? Well, let's see. I think we have maybe just enough room to do this. Okay, 2 plus 1 is 3. So 5 minus 6 times 3. 6 times 3 is 18. 5 minus 18 is -13. And 1 minus 14 is -13. Woohoo! All right, so the solution is 1. All right, next example. We have 4 times 2 plus x plus 1 equals 7x minus 3 times x minus 2. So kind of similar to the last example, maybe just a little bit more complicated. Step 1 does not apply. We don't have any fractions. Step 2 is to get rid of parentheses, and we do have 2 sets of parentheses in this one. All right, so we're going to distribute that 4, and that's going to give us 8 plus 4x plus 1. This is still a plus 1 equals 7x. Now be careful here because we're distributing a -3. So that's going to make this minus 3x, but it's going to make the other term plus 6, right? Because -3 times -2 is positive 6. All right, step 3 is simplify the left side. 8 plus 1 is 9. And also simplify the right side. 7x minus 3x is 4x. All right, so left side and right side are completely simplified. Step 4, use the addition property of equality to get the variable terms on one side and the numbers on the other side. So let's say that I stay in the habit of putting the variable term on the left side. That means specifically I want to get rid of this 4x. I don't want a variable term on the right side. However, something weird happens. It just so happens that the variable term on the other side is also 4x. So not only is this going to drop out, which is what I was trying to do, but this is also going to drop out. And I end up with something that looks really weird, right? I end up with something that says 9 equals 6. So what does that mean? Well, officially what it means is, remember we talked a little bit in the last section, when you do these operations on both sides of the equation, you're supposed to get an equation that is equivalent. So what's happening here is that all the values of x that make this equation true are the same values of x that make this equation true. So what are the values of x that make this equation true? Well, the answer is none. There are no values of x that will ever make 9 equals 6. My high school math teacher in a situation like this would say LLPOF, which stands for liar, liar, pants on fire. I've kind of updated it for the 21st century. I'm trying to make it into a hashtag LLPOF. One of these days, I'm hoping that will catch on and, go viral. Hasn't happened yet. Maybe you can help me. All right. But what this means, whenever you get a statement that is never true, like 9 equals 6, that means the equation has no solution. There are no values of x that make this equation true. Okay, so that's how you recognize that kind of equation, because the variable will always completely drop out and will leave you with a false statement, a statement that is never true. All right, next example. Now we've got our fractions. Okay, don't panic. All right, so step 1 said to multiply both sides by the LCD in order to get rid of the fractions. So let's talk about what is the LCD for this equation. Just imagine that you were trying to add these 3 terms together. That's not what we're trying to do. But if it was what we were trying to do, what would all of those denominators have to be? I would need to make them all 8s, right? So that means that the LCD is 8. So I am going to multiply both sides of this equation by 8. So let's see what that does. On the right side, we have 3/4 x times 8. And why don't we call that 8 over 1? 4 divided by 4 is 1. 8 divided by 4 is 2. So all that's left there is 3 times x times 2, which is 6x. So we've gotten rid of the fraction there. The left-hand side is a little bit more complicated. So let's see what happens there. I'm going to distribute the 8. So I'm going to have an 8 parked in front of this term, an 8 parked in front of this term. And we're going to have 8 times 7/8 x plus 8 times 1/4. And if you find this helpful, let's go ahead and drop that in there. In this term, the 8's just completely drop out and leave me 7x. And in this term right here, 4 divided by 4 is 1. 8 divided by 4 is 2. And all that's left is 2. So I don't know about you, but I like this equation a whole lot better than I like that equation. All right. Okay, so I think everybody knows what to do now, right? We don't have any parentheses to get rid of. The left-hand side and the right-hand side are completely simplified. So now we have to get x's with x's and get numbers with numbers. So for the first time, I am going to recommend doing something different than just automatically putting the x on the left side. In this case, I am going to recommend that we do minus 7x on both sides, put the variable on the right side. And the reason I'm recommending that in this problem is because the only number term, the 2, is already on the left side. So that'll make life a little easier. 6x minus 7x is negative 1x. And now we need to get rid of the negative 1. So we'll divide both sides by negative 1. And I think that the solution is x equals negative 2. Okay. But we are due for a check. So let's check this. So luckily I left a blank page here. We do have to check it in the original equation, which was 7/8 x plus 1/4. So I'm going to go 7/8 blank plus 1/4 equals 3/4 x. So we'll make that 3/4 blank. And we think the solution is negative 2. So let's put a question mark there. We'll drop our fence down. Okay. And we're going to hope that the left side comes out to equal the right side. So let's start with the right side since it's easier. Put a 1 here. 2 divided by 2 is 1. 4 divided by 2 is 2. So the right side comes out to negative 3 halves. Okay. So that's what we'll hope the left side comes out to. Put a 1 under here. 2 divided by 2 is 1. 8 divided by 2 is 4. So we have negative 7/4 plus 1/4, which is negative 6/4, right? So is this looking like it's going to work out? Well, yes, it will, because negative 6/4 is not in simplest form, is it? 6 divided by 6 is, 6 divided by 2 is 3. 4 divided by 2 is 2. The left side and the right side both come out to negative 3 halves. Woohoo! Okay, so don't forget, that means the solution is negative 2. I've had students sometimes get mixed up and they think the solution is negative 3 halves because that's what came out at the end of the check. Okay, but it is negative 2 because that's the number that I put in to make the equation true. All right, next. Let's look at this example. All right. We have an equation with decimals. 0.03 times 2m plus 7 equals 0.06 times 5 plus m minus 0.09. So let me tell you, I've been doing this for a long time. And there are two different ways you can deal with an equation that has decimals. One option, which I'm not going to do this time, is you can multiply both sides of this equation by 100. And that will get rid of all the decimals. Or you can not do that and just deal with the decimals the way they are. However, if you decide to go that route, which is the way I'm going to do it, I strongly, strongly, strongly recommend, and this did not come from my high school math teacher, this came from me. What I say in this situation instead of LLPOF is DBAH, and we can make that a hashtag. DBAH stands for Don't Be a Hero. And what I mean by that is use your calculator, right? I find that people are not quite as good at doing arithmetic with decimals as maybe they used to be, right? Everybody's got a calculator in their phone, so, it's understandable. Don't be a hero, though. You've got a calculator. You're allowed to use a calculator. Use it, all right? So we'll start by distributing 0.03 and also 0.06. And that's going to give us 0.03 times 2m would be 0.06m plus 0.03 times 7, which is 0.21, equals 0.06 times 5 is 0.30. 0.06 times m is 0.06 m. And then we have the minus 0.09. Okay, so that was step, 2. Step 2 is where we get rid of parentheses. Step 3 is where we combine like terms. There are no like terms on the left side, but there are on the right side. We have these two real numbers here with no variable attached. So 0.06 m plus 0.21 equals 0.30 minus 0.09 is 0.21, and we'll keep the 0.06 m. All right. Step 4 is where we put variables on one side, numbers on the other side. So let's say again that I am planning to put the variables on the left side. Then I would zero in on that term and undo that. Oh, but does this situation look kind of familiar? It just so happens that we have the exact same term over here. So not only is this term going to drop out, which is exactly what I was trying to do, but so is this one. But look at the statement that it leaves me. It leaves me 0.21 equals 0.21. Is that a lie? Should I say liar, liar, pants on fire? No, that is not a lie. That's saying one number equals the same number. So what do you think that should mean? Every value of m, or I should say the values of m that make this equation true are the same values of m that make this equation true. What values of m make 0.21 equal 0.21? Well, the answer is all of them. 0.21 is always equal to 0.21. All right, that equation is always true. Therefore, the equation that I started with must always be true. So in this situation, what you say is the solution is all real numbers. You can put any number you want into this equation, and it will make it true. Okay, try it. Pick your favorite number, put it into that equation. It should come out that the left side equals the right side, even if everybody picks a different number. Okay. This type of equation is called an identity. An identity is an equation that is always true. All right. And that is going to do it for section 2.3. We will see you next time.